Hello there, I am Dr. C.N. Okolugbo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis for business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. You're welcome once again to my channel. Thank you for joining me once again. Today we are going to look at another example on determining correlation coefficient of two variables. We have another example on the board. Let's look at what we have. As you can see on the board, we have correlation coefficient and example 3. The manager of a rice mill intends to establish the relationship between loss of man-hour due to lateness of workers, represented by X, and the production output. The following data obtained for a week is given below. As you can see, we have 7 entries. So let's assume that the first one is on Monday and the last one is on Sunday. So they observe some lateness in terms of man-hour combined of workers. They will have the output. So we want to find the relationship between lateness and output. To determine this, we'll do as we've been doing. All right, solution here. And then we'll enter our X and Y values in our table. Here we have X and then we have Y. For X, we have 240 and 192, 186, 170, 150, 136, and 120. Then the entries for Y are 45, 59, 60, 64, 71, 85, and 90. Now after you've done this, the first column we need to determine after the X and Y is the product of X and Y. That's what we need. We need X times Y, the product of X and Y. And if we multiply X and Y on this, the first one will give us 10,800. The second one will give us 11,328. The third one will give us 11,160. The next one will give us 10,880. 150 times 71 will give us 10,650. And then 136 times 85 will give us 11,560. And then the last one, 120 times 90 will give us 10,800. So that's what. All right, so this is what we have. What's the next column we need to determine? What do we have to determine next? That is X square. Yes, X square. So that is finding the square of these values. And the first one, square of 240, will give us 57,600. The square of 192 will give us 36,864. The square of 186 will give us 34,596. I trust you're doing this with me with your calculator. Make sure you have your calculator with you and you're solving this. Now the square of 170 will give us 28,900. The square of 150 is 22,500. The square of 136 will give us 18,496. The square of 120 will give us 10,800. So that's what we have. The next one we need to determine is the square of y. The square of y. That's finding the square of these values. And the first one, the square of 45, will give us 22,225. The next one, square of 59, will give us 3,481. The square of 60 will give us 3,600. The square of 64 will give us 4,096. The square of 90 will give us 5,041. The square of 85, I trust you are following. The square of 85 will give us 7,225. And the square of 120, alright, I beg your pardon, the square of 90 will give us 8,100. So this is what we have. The next thing we do after determining these three columns from what we have, the first initial values we've given, we'll find the summation of each of the columns. And the summation of each of the columns, if we sum these values, we'll have 1,194 here as the sum of x. The sum of y will give us 474. The sum of xy, can you do this quickly? The sum of xy should give us 77,178. The sum of x squared will give us 213,356. Okay, then the sum of y squared will give us 33,568. Okay, so that's what we have as our values. From here, we will now determine the correlation coefficient represented by R. And we have the R here. So let's write the formula. Can you remember the formula? The formula is N summation xy. The N is the number, summation xy minus summation x summation y, all over the square root, long square root of N summation x squared minus summation x all squared, we close the bracket, times N summation y squared minus summation y all squared, I will close the bracket. So this is the formula to find the correlation coefficient. So we use these values as we are given, the summation values, to fill into this formula. Let's quickly do that. So that here N is 7. You can see 1, 2, 3, 4, 5, 6, 7. N is 7. So we have 7 here into 7 times summation x y, sum of summation x y. We have 77,178 as given, minus summation x is 1194 times summation y is 474. That's what we have. So divided by the square root, we have a long one here, so that here, what is n? N is 7 again, times summation x squared. These are x squared. Summation x squared is 213,356. Okay, minus summation x, which is 1194 494 all squared, and we close this bracket and we open another one to accommodate y, so that we have 7 into summation y, this summation y here, so y squared, I beg your pardon, so there's 3, 5, 6, 8, close bracket, minus y squared, y summation y all squared, so this is 474 all squared, and we close bracket. So these are the values we want to deal with. Let's start putting in the figures, so that this one 7 times this value should give us 540,246 minus the product of these two, the product of 1194 and 474 should give us 565,956. Told you the values are quite extensive, so we have to be careful. Divided by the square root of let's find this value. So 7 times 21, 213,356. That should give us 1,493,492. Okay, minus the square of 1194. Square of 1194 will give us 425,636. Okay, open bracket again. We now find this one, the product of 7 and 33,568. That should give us 234,976 minus 224,676. So that's what we have. All right, we continue here, finding this value. So this, the difference between this and this, will give us minus 25,710 divided by the square root. We're still having the square root of 67856. Okay, that's what we have, times 10,300. That's what we have. Okay, we still continue here by we need to determine this value to know what we're going to find the square root of. So this becomes minus 25,710 divided by the square root of, wow, this is a long figure. It's a very long figure. Square root of 698,916,800. Okay, we have to find the square root of that, and the square root of that will give us, this is 25710 divided by the square root of this. The square root of this will give us 26437.03. Okay, from the previous examples we were given earlier, you will recall I said that at the time you're getting to this point, the denominator should be greater than your numerator, so that you are going to have a fraction, so that you are going to have a decimal, because correlation coefficient should result in a fraction, should result in a decimal, so that our answer, let's leave it this way. Our answer for R, remember this is R, our answer will be minus 0.97. 0.19724. So this is approximately 0.97 minus 0.97. This means that the relationship between lateness at work or loss of manpower and output is very strong, but there's an inverse relationship between the two. So there's an inverse relationship between manpower and then output. So that's what is in there, showing the negative relationship. Now our R squared, this is our R, this is our R value. Our R squared to find the square root, to find the square of 0.97. So find the square of 0.97, and that will give us 0.95. That will give us 0.95. So this is our R square, as you can see on the board. I want to encourage you to still go through this example again and look at all the lines that you need to check out. Now let me point out something here, that by the time you get to this point and you want to find the square of minus 0.97, you have to put it in brackets. You have to put it as minus 0.97 exponential 2 for you to get this value. If not, your answer will be a negative. All right, thank you very much. I will expect to hear a word or two from you in the comment section, and as well, please do subscribe to this channel. God bless you.